welcome back to the video tutorial series of the mobile computing and wireless communication. I am your instructor Varshata. Let's start our lecture series. So topics to be covered in this lecture, that is spread spectrum, types of spreading techniques and frequency hopping spread spectrum. Okay, so first of all we will see what is the spread spectrum. As you know, we have discussed about what is spectrum in unit 1. So spectrum ultimately what we can say, the spectrum that is used to transmit the signal. So that is what one environment in which we can transmit the signal, that is known as spectrum. Okay, so here first of all there are several problems in communication system. Which problems are there? Let's discuss it. So here you can see first problem is what? Utilization of channel bandwidth effectively. We cannot utilize the channel bandwidth effectively. For example, you have 500 kilohertz bandwidth. Are you going to use the each and every range of that particular spectrum or that particular bandwidth? Okay, so there are some issues. So that issue without spectrum we cannot solve. So we should have to use the spectrum technology. Then next, second number is what? Minimizing of the amount of transmitted power. Okay, so we cannot minimize the transmitted power without the spectrum. So that is one of the disadvantage in communication system. And security, okay, in spectrum we can encode the signal, then at the receiver side we can decode the signals. Okay, so that type of security will be provided in spectrum. Now next is what? The last is the channel should immune to any kind of external interference. As I told you that the third problem is what? Security is not there, so external interference may be there. Okay, so these are the common issues in communication system. So why spectrum is necessary? So to solve all the problems we require the spectrum. So here it is written that this is all the problems can be solved by the spread spectrum modulation. So that's why spread spectrum technology is useful. Okay, so now next is what? Characteristics of the spread spectrum signal. So which are the characteristics? As we have discussed in the last slide, the disadvantages of the communication system without the spectrum technology. So that we will consider also as a characteristic, as an advantages of this spread spectrum technology. Now here learn spread spectrum signal is one pseudo-random signal. So it appears like the random noise. Okay, so pseudo-random signal, that means what? We can generate it as a random signal, we can combine it with the original signal, and we can generate a new signal, and that signal will be traveled in a spectrum technology in a bandwidth, and it will reach to the receiver side. Got it? Okay. For second point is what? It occupies a large bandwidth than the original signal to transmitting power is less. Okay, it occupies the entire bandwidth and as well as it required the less power. Then next one is what? It uses some kind of coding. By this coding, the signal information is independent of the spread spectrum signal. Some kind of coding, that means you can encode the signals in a specific format. Okay, we will see the CDMA encoding and decoding in this unit. Okay, then next is what? Separation of noise and original signal is possible. When you are going to use the spread spectrum technology, you can separate the noise signal as well as the original signal. So that is also one of the advantages of the spread spectrum technology. So now do you understand which are the characteristics of the spread spectrum signals? Now let's see which are the disadvantages. Each and every technology which have the advantages, that also have the disadvantages. Okay, so which are the disadvantages? First disadvantages is what? Complexity of receiver that have to be disparate the signal. As you are going to spread the signal, you should have to disparate at the receiver side. Then only that receiver can understand what the original signal is. Okay. Then second disadvantage is what? Large frequency band is needed due to the spreading of the signal. For example, you are spreading the narrowband signal to the broadband signal. So that's why you require the large bandwidth, large spectrum. Okay. Then next, spread signal appears more like a noise. Okay. If you are spreading the signal, then it will appear like a noise. They still raise a background noise level and may interfere with other transmission if no special precautions are taken. As you are going to spread the signal, it will become a noise interfere. Okay, so noise will be there much more compared to the original signal as you are going to spreading it. Okay, but here you can you can separate the noise signal as well as the original signal. Okay, so these are the disadvantages of the spread spectrum technology. Now here you can see that this is the block diagram for the spread spectrum technology. What will happen when signals is going to be transfer in the spectrum. So first of all, there is an input message that will be transferred to the channel encoder. Channel encoder will transfer the signal to the modulator, and modulator will use the spreading generator. The spreading generator will generate the pseudo-random signal, and that pseudo-random signal will be combined with the modulator, and that combined signal, that is your transmitter signal or the spreading signal, that will be transmitted in a spectrum, and that will be reached at the receiver side. So what will happen at the receiver side? It will received by the demodulator. Again, the spreading generator will apply the spread pseudo-random signals that will be same applied at the receiver sender side. Okay, and it will demodulate the signal, and channel decoder will again decode it, and it will generate the original signal, so that output message will be received by the receiver. So this is the process that will be followed when your signals will be transmitted from transmitter to receiver. Okay. Now next is, which are the different types of spreading techniques? Okay, so spread spectrum modulation technique is classified depending on their operation concept. Which type of operation concept is there? Based on that, this technology is classified. So here you can see the spread spectrum may be averaging type or avoidance type. So what is this averaging type and avoidance type? So let's see. First of all, averaging type. So in this system, the interference is reduced by averaging if over the log period. Okay, so you can reduce the interference by averaging its log period. Now next is what? Avoidance system. So what is avoidance system? In this system, the interference is reduced by making the signal to avoid the interference at the large fraction of time. Here we can avoid by averaging the log period, and here we can avoid by avoiding the interference. Okay, so these are the basic two types of different spreading techniques. So let's see which are this different types of technique is that. So here you can see the spread spectrum technology has basically two types. Which are the two types? First is the averaging type, and then next is what? Avoidance type. So in averaging type, we have the direct sequence spread spectrum technology that we will see in our syllabus. So that in upcoming lecture we will see what is the FHSS. Okay, now next is avoidance type. So this four technologies that is known as the avoidance type. First is frequency hopping spread spectrum, that is FHSS. Then next is a time hopping, and then chip technology, and then hybrid technology. Okay, so in frequency hopping technology, we will define different frequency. In time hopping, we are defining different times, and chip we will use some chipping sequence, different chipping sequence, and hybrid will be the combinations of the advantages of one or two technology. Okay, so let's see about this in brief. So here you can see, first of all, DS, that is direct sequence spread spectrum. So DS spread spectrum is typically used to transmit the digital information. So whenever we want to transmit the digital information, we should have to use this DS. Common practice in DS system is to mix the digital information stream with pseudo-random noise. So whenever we are using the DS, direct sequence spread spectrum, we should have to combine the original signal to the pseudo-random signal, that we will see. Then next is frequency hopping spread spectrum. Frequency hopping is a form of the spreading in which the center frequency of a conventional carrier is altered many times, okay, within a fixed time period like 1 seconds, like 1 microseconds, in accordance with the pseudo-random list of the channel. Okay, so frequency will be altered. For example, signals will be traveled for 1 second in the F1 frequency, then F2 frequency, then F3 frequency, then again F2, then F1. So like this way. So that it will change according to the pseudo random number of the frequency. So that is what the frequency hopping spread spectrum. Okay. Now next is chirp. Chirp, that is a third spreading method, employs a carrier that is swept over the range of the frequency. So that means it is about the chirping sequence chirp technology, but we are thinking that in chirp technology we are swapping the frequency every time whenever the signal is going to be transmitted. Okay, so swapping of the frequency will be done in the chirp spread spectrum. This method is called the chirp spread spectrum and finds its primary applications in ranging and radar systems. Okay, in our syllabus we will see the DSSS and FHSS. Now next is the time hopping. Okay, so that last spreading method is called the time hopping. In a time hop signal, the carrier is on off keyed by the pseudo random noise sequence, resulting in very low duty cycle. So here in time hopping signal, your signals will be on, signals will be off depending on the digital which type of digital informations they are carried. Okay, the speed of keying determines that amount of signal spreading. Now last one is a hybrid system. Okay, so hybrid system is what? It is the combinations of above four technologies. So two or three technologies will be combined to provide the hybrid system. Okay, so let's see frequency hopping in spread spectrum. Okay, in FHSS, that is frequency hopping spread spectrum system, the total available bandwidth is split into many channels of the smaller bandwidth. That means we are going to divide the entire bandwidth in a different channels, so we can occupy each entire spectrum. Okay, plus guard space between the channels. So guard space is necessary, that will prevent the interference of the signals. Transmitter and receiver stays on the one of the channel for a certain time, then hop to the another channel. So that hop is based on the time that is defined for 1 second or 1 microsecond, etc. The pattern of the channel uses is called as a hopping sequence, and at the time spent on a channel with a certain frequency is called the dwell time. Okay, so for which particular time that particular signals will spend on that particular frequency, so that time is known as a dwell time. Okay, and sequence is known as the hopping sequence. Okay, so here you can see the frequency hopping spread spectrum that is similar to the block diagram of the spread spectrum. Modulator is there, and code generator will generate the frequency table, and according to the frequency table, frequency synthesizer will synthesize the frequency of the signal, and that combined signal will be transmitted through the channel. Okay, in a network through the spread spectrum, and at the receiver side it may be possible the code generator will be used, and then again frequency table will be used. Through this frequency table, frequency synthesizer will decode the signals, and we can use the bandpass filter to remove the noise, and that signals will be demodulated at the receiver side, and that will be the output. So this process will be followed when we are considering the frequency hopping spread spectrum. Okay. Now, in frequency hopping spread spectrum, we have two types, which are slow frequency hopping and fast frequency hopping. Okay, so what is this slow frequency and fast frequency? Let's see. So here you can see this is the diagram for the slow frequency hopping and fast frequency hopping. So here you can see this is what? Your signals 0, 1, 0, 1, 1, 1. So that is going to be transferred, that is user data. And here this is a slow fade, a slow hopping, and this is what? A fast hopping. Okay, so this slow hopping, that is a slow spread spectrum technology, and here fast frequency hopping spread spectrum technology. So what will happen in slow hopping? Slow hopping, that means 3 bits per hop. This is just defined 3 bits. You can any numbers of bits can be used per hop. Okay, 3 bits per hop. So 3 bit will be transferred on the same channel. After that time, the channel will be changed. So that is what slow hopping. We are using bits per hop. So if bits per hop is there, then it is a slow hopping. But if it is a hop per bit, okay, so hop per bit, then it is a fast hopping. So here you can see for one particular bit there are 3 hops. Okay, so for transmitting the one particular bit, 3 times the signals will be swapped to the different frequency. So that is what fast hopping. Here TB is known as the bit period and TD is known as the dwell time. Dwell time, that means for which particular time that signal will spend on same frequency channel. So that is known as the dwell time. Got it? So this is what slow hopping and this is what fast hopping. Okay, so summary of this lecture, we have learned about what is spread spectrum, what are the advantages and disadvantages of the spread spectrum. Then we have learned about the types of the spread spectrum technology. Total there are 4 types is there. 2 of them we are going to study here. So that is FHSS and DSSS. Then we have learned about the hybrid chip sequence and time hopping sequence. And then we have seen the one of the type, that is frequency hopping spread spectrum. Got it? So this is all about this lecture. Remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture with a new topic. Thank you.